You probably don't need fine-tuning, or at least not for the reason you think. A lot of people build an LLM app, get a bad answer and immediately think, okay, maybe I need to fine-tune the model. But a bad answer doesn't automatically mean the model needs fine-tuning. Sometimes the model gives a bad answer because it doesn't have the right information. Other times it has the information, but it doesn't respond in the format or style that you want. And those are two very different problems. Hi, welcome back to my channel, and if you're new here, my name is Anna, and on this channel I explore machine learning concepts in a simple and intuitive way. So in this video I want to give you a practical way to decide when you should use RAG, when you should use fine-tuning, and when you might need both. The simple version is this: use RAG when the model needs knowledge, use fine-tuning when the model needs behavior. That's the main idea, but let's make it concrete. When an LLM gives a bad answer, the first question should not be, should I fine-tune it? The first question should be, why was the answer bad? Because bad answer is not specific enough. Imagine you are building an internal chatbot for a company. Someone asks, how many vacation days do full-time employees get? And the model might guess and say, full-time employees get 15 vacation days. Or if it's careful, it might say it does not know. But your actual company policy says full-time employees get 25 vacation days. But what is the failure here? It's probably not because the model has the wrong tone. It's not because the model is bad at writing. It's not because it needs to learn a new style. The issue is that it didn't have access to the company policy. That is a knowledge problem. And knowledge problems are usually where RAG makes sense. RAG stands for Retrieval-Augmented Generation. I covered RAG in more detail in another video, but the basic idea is simple. Before the model answers, we search some external knowledge source and give the model the relevant information. So instead of hoping the model already knows your company policy, we retrieve the policy and put the relevant part into the prompt. That means the model is not answering from memory, it's answering with context. This is why RAG is useful for things like fresh information, private company documents, product documentation, research papers, legal documents, support articles, or anything where you want citations. A good way to think about RAG is, RAG gives the model something to read. It's like an open book exam. If the answer depends on the document, give the model the document. For example, if a user asks, what does the vacation policy say? We don't want the model to guess. We want it to look at the policy. That also makes the system easier to update. If the company policy changes from 25 to 28, we don't want to retrain the model. We just want to update the document. This is one of the biggest reasons RAG is so useful. It separates the model from the knowledge base. The model handles language. The retrieval system handles finding the right information, and the documents stay editable. So if our problem is the model doesn't know something, then fine-tuning usually is not the first thing we would reach for. We would first ask, can we retrieve the missing information and give it to the model? Most of the time that is a better starting point. Now let's make the RAG idea concrete with a small local demo. I am using Ollama here, so the model is running locally. And for retrieval, I'm using a local embedding model, so this is closer to what a real RAG system would look like. We embed the documents, embed the question, and retrieve the chunks that are closest in meaning. First, we have a small internal knowledge base for a fictional company. There are HR policies, security policies, travel rules, and remote work rules. Now we ask the model a simple question. How many vacation days do full-time employees at company A get in 2026? Without RAG, the model does the right thing. It says it doesn't have access to the internal company policy. And that is the point. The model is not bad at language. It's not failing because it needs a new style. It's failing because the information is not in the context. So now we build the retrieval step. We split the documents into chunks, embed those chunks, and then search for the chunks that are most relevant to the question. Here the retriever finds the paid time off policy, and the top chunk says, full-time employees receive 25 vacation days per calendar year. Now we put that retrieved context into the prompt and ask the model again,
This time, the model answers correctly. Full-time employees receive 25 vacation days, and it cites the policy document. So this is RAG. The model didn't need to memorize the company policy. It just needed to see the right document at answer time. That is why RAG is a good fit for private documents, changing policies, citations, and fresh information.
So that was a knowledge problem. The model failed because the right information was missing. Now let's look at the second kind of failure, behavior. In this case, the model may understand the input perfectly well, but it still doesn't respond in the format, pattern, or tone we need.
Here we have customer support messages, and we want the model to convert each message into a strict JSON schema. For example, this message, "My package was supposed to arrive last week and it still isn't here," should become something like intent, shipping delay, sentiment, negative, priority, medium, and requires human, false. First, we ask the model in a vague way, what should we do with this customer message? And the model gives a helpful paragraph. That answer is not completely wrong. It understands the situation. But for our product, it's wrong because we need structured JSON. So here the issue is not missing knowledge. The issue is behavior. We can measure that directly by validating the output. The first response fails because it's not valid JSON. Then we give the model a much stronger instruction. Return only JSON. Use these allowed labels and follow this schema. Now the output passes validation. This is important because we don't always need fine-tuning immediately. Sometimes a better prompt, structured outputs, and validation are enough. But if this task happens thousands or millions of times, and we need very consistent behavior, then fine-tuning starts to make sense. And if we decide to fine-tune, the training data would not be a document dump. It would be examples of the behavior we want. So for example, customer message in, exact JSON out. So now we can define fine-tuning more clearly.
For fine-tuning, possible use cases are when you want to always return a specific JSON schema or classify text into your exact categories, write in a specific tone, follow a repeated pattern, or handle a task in a very consistent way. So I would describe fine-tuning like this. Fine-tuning teaches the model a pattern. It's not mainly giving the model a document to read. It's about showing the model many examples of the behavior we want. Then the model starts producing the desired format. So if we have hundreds or thousands of examples like customer message in, structured JSON out, or document in, classification label out, fine-tuning can help the model become more consistent. But I would still not make fine-tuning the first step for every problem. Before fine-tuning, I would usually try a better prompt, a few examples in the prompt, structured outputs, or better evaluation. Fine-tuning is more attractive when the task is repeated many times. The expected behavior is clear and we have good examples. The examples matter a lot. If our training data is messy, fine-tuning won't magically fix that. It may just teach the model our mess. So fine-tuning is powerful, but it's not magic. It works best when we can clearly define what good behavior looks like.
That is the difference. If the answer depends on the document, retrieve the document. If the model has enough information but keeps responding in the wrong format, tone, or pattern, then think about behavior-focused methods, prompting, structured outputs, and eventually fine-tuning.
So the clean comparison is this. Use RAG when the model needs to look something up. Consider fine-tuning when the model needs to learn a repeated response pattern at scale. If the model lacks fresh facts, use RAG. If it needs private company documents, use RAG. If you need citations, use RAG. If the facts change often, use RAG. But if the model keeps producing the wrong format, fine-tuning might help. If it needs a very specific tone, fine-tuning might help. If it needs to classify examples into your exact labels, fine-tuning might help. If it needs to follow a repeated task pattern, fine-tuning might help. Another way to say it is RAG changes what the model can see. Fine-tuning changes how the model tends to respond. That is probably the most useful mental model. In real systems, we often need both. For example, imagine a customer support assistant. It needs RAG because it needs to look up the latest refund policy, shipping policy, warranty rules, and product details. But it may also need fine-tuning because we want it to answer in a consistent support style. So RAG gives it the facts. Fine-tuning gives it the behavior. Or imagine a legal assistant. We may use RAG to retrieve the relevant contract clauses, but we might fine-tune the model to summarize them in a specific structure. So RAG and fine-tuning are not enemies. It's not always one or the other. They solve different parts of the problem. The mistake is using one to solve the problem that the other one is better suited for. Don't fine-tune a model just because it lacks access to a document. And don't expect RAG to fix a model that refuses to follow your format. So here is the decision rule I would use. If the model is missing information, use RAG. If the model has the information but responds in the wrong format, tone, or pattern, start with prompting, structured outputs, and evaluation. If you need that behavior consistently at scale, then consider fine-tuning. If it needs both external knowledge and consistent behavior, use both. But start with the diagnosis. Don't ask, should I use RAG or fine-tuning? Ask, what kind of failure am I trying to fix? Because once you understand that, the choice becomes much easier. RAG gives the model information at answer time. Fine-tuning changes the model's behavior through examples. So the simple rule is, use RAG when the model needs knowledge. Consider fine-tuning when the model needs repeated behavior at scale. I also have videos on vector search, embeddings, and linear regression if you want to go deeper. If you found this helpful, feel free to like the video and leave a comment. It really helps more curious minds like yours discover the channel. And if you want more videos like this, consider subscribing so you don't miss future videos. As always, all the resources, including the code, will be in the description below. Thanks for watching and I will see you in the next one. Bye!